actions. Remember what I discussed in the previous class about the classification of the various points. We do classify the points as stationary or critical or saddle or point of impact. So I discussed what is the difference between all these four. What is the stationary point? The stationary point is a point where that first derivative becomes zero. First derivative becomes zero such that it has extrema. So that extrema may be local or a global. That means it may have a local maxima, local minimum, or a global maxima, global minimum. So the point where the first derivative becomes zero, that is called stationary point. That means f dash x should be 0 and that x is called stationary point. So that at that point you may have local extrema or you may not have a local extrema. Both are called stationary points. But specific case of not having any extrema is called saddle point. So saddle point is a stationary point. That means it's f dash derivative first derivative becomes 0, but it does not have any extrema. That is what the definition between stationary and saddle. Stationary, saddle, both f dash becomes 0. But stationary point, it has local extrema. But saddle point does not have the local. Then what is critical point? I told you. It's a point where again f dash x 0 or f dash does not exist. Both the cases fall under the critical points. Either your first derivative becomes 0 or f dash, that is the first derivative does not exist case. Both will be critical points. But the last case, point of inflection is if your f double dash becomes 0 and your curvature changes when x changes. So for negative x's you have concave up or concave down, and for positive x you have convex. It means if it is concave up, you will get concave down. Now given f of x is equal to x cube. Fine, I asked you to test for the stationary, saddle or whatever may be the point existing. Now what is f dash x? F dash x? So f dash x, can it become 0? Yeah, definitely. When x equal become, it will 0 na. So keep f dash x equal to 0, find x. X will become 0. Now f dash x, x becomes 0. So f dash x, when x becomes 0, so x is equal to 0 is a stationary point for the time being. Now is it stationary point, saddle point or inflection point? We have to check. So x equal to 0, check for saddle point. What is the condition for saddle point? It should not have extrema. How to check extrema is there or not? Check for f double dash. If f double dash less than 0 maximum, f double dash greater than 0 minimum. So check for f double dash at x equal to 0. So f double dash x becomes 0. So that means there is no maxima, no minima. That means no extrema exists. So x equal to 0 is a. At the same time, check for point of inflection. Because f double dash 0 means I asked you to check for point of inflection. Take x negative, take x positive, check the sign conventions. What is f double dash? 6x. When x becomes negative, minus. When x becomes positive, plus. So x equal to 0 case, if your f double dash becomes 0 and your sign also curvature changes. So x equal to 0 is also a point of inflection along with saddle point. Saddle point is confirmed. How it is saddle point is confirmed? Because there is no extrema exist. Your f dash becomes 0, so x equal to 0 is a stationary point time being. But I have checked for the extrema existing or not. Extrema is not at all existing because f double dash at x equal to 0 is becoming 0. No greater than, no less than. If greater than 0, I say minimum. If less than 0, maximum. But it becomes 0. So no extreme also saddle point. Confirmed. Now I already checked for the point of inflection because f double dash becomes 0. So whenever f double dash becomes 0, you check for this inflection point. How? Check the curvatures. Take negative value, take positive value. So here in this case, you got negative and positive, both on the other sides. So x equal to 0 is a saddle point along with point of inflection. Clear? Okay. Now my question is, for single variable functions, you have for single variable functions, now we have checked for the stationary, saddle and inflection points. Now let us look at for the multivariable functions. For multivariable functions, how to check for this stationary saddle points? So note down. Let a comma b be a stationary point. Let a comma b be a stationary point, so that fx, that means dou f by dou x becomes 0 and fy, that is dou f by dou y equal to 0 at a comma b. Then what are the conditions? First condition, if fxx into fyy minus fxy square less than 0, then a comma b is a saddle point. Second point, if fxx into fyy, what is fxx? Fxx is dou square of by dou x square. What is fyy? Dou square of by dou y square. What is fxy? Dou square of by dou x dou y. That means dou f by dou y is differential again with dou by dou x. Right? So fxx into fyy minus fxy square, if it is greater than 0, then either maxima or minima. How we can say maxima or minima? I again given some subpoints. If fxx less than 0 and fyy less than 0, at that point a comma b, it is a case of maximum. Same single point. If fxx greater than 0 and fyy greater than 0 at AB, then it is a case of minimum. Then the last point, if fxx into fyy minus fxy square, if it is becoming 0, then we do not have enough information. We do not have enough information to classify the point. This is what the convention for multivariable functions. See, for single variable function we have already done. Lot of problems we have done. Till last class or now, what is the function I given? The single variable. Now for multivariable, that means you are involved in x, y, z. More than one variable is called multivariable. Now in that case, how we will check for the saddle points or critical points or point of inflection. Okay. Now what is the point here he mentioned? He mentioned that let A comma B be a stationary point. That means what? For multivariable functions, first of all we need to estimate the stationary point. How we estimate stationary point? For single variable, how we estimate the stationary point? Take the first derivative equal to 0. Here also, take the first derivative, that is fx, dou f by dou x equal to 0. Similarly, fy, that is dou f by dou y equal to 0. Get equal to 0, get the a comma b, that is your stationary point. So once we estimated the stationary point, then your conditions apply. Okay, how it is applying? See, now after estimating the stationary point, how I estimated the stationary point? Take the first derivative equal to 0. Because two variables are there, take with respect to x, take with respect to y, equal to 0, get the point. That is stationary point. Then, take fxx, that is dou square f by dou x square. Take fyy, dou square by dou y square. You multiply it. Subtract from xy whole square. What is fxy? Dou square f by dou x dou y. Take whole square, subtract it. Now this fraction, if it is less than 0, then at that point a comma b will be a saddle point. Let us suppose this what is here we have written fxx into fyy minus fxy whole square. If it becomes greater than 0, then there may be a maxima or a minimum. How we will check maxima or minimum? Two conditions. Both fxx and both fy both are less than at that point, then you have case of maximum. If both are greater than 0, fxx as well as fyy, at that point we got minimum. Let us suppose this product fxx into fyy minus fxy whole square becomes 0. See, less than 0, greater than 0, we have written the conditions. Sometimes it may become 0. At that point, for multivariable function, we does not have enough information to classify the points. That's all. So sometimes there is a case that this thing will become 0. Then we cannot classify the point, whether the point is a critical or a stationary or a saddle or a point of inflection, we cannot, because there are some other constraints. There is another theorem is there that is not in the syllabus, so don't worry about it. Clear? So many of the problems will lie in these two conditions only. So no one will go beyond this point. Understood? So note down the problem. F of x comma y is equal to x square plus y square. Multivariable function given. F of x comma y is equal to x square plus y square. Now check for points. Now first estimate the stationary point as I told. How to estimate the stationary point? Take dou f by dou x equal to 0, dou f by dou y equal to 0, get x comma y, that is stationary point. So your stationary point is 0 comma 0, very good. So now your stationary point is 0 0. Now you go for checking of whether that stationary point is a saddle point or that point have some extrema, that is maxima or minima, or we does not have any information. We check. So estimate dou square f by dou x square, dou square y by dou y square, dou square f by dou x dou y. So 0 comma 0 is a stationary point. So one thing is clear. Now at this stationary point we need to check for these conditions. Now what is the first condition? What is fxx? Fxx 2, very good. Fy by 2, very good. So fxx is 2, Fy is 2. What is fxy? Dou square f by dou x dou y becomes 0. Now what is the product? 4. So fxx check for these things. If both are negative maxima, both are positive minima. Now check for fxx and fyy. Both are positive. So 0, 0 point has minima. So now what is 0, 0 now? Stationary point or saddle point? Stationary point. What is the meaning of stationary point? It has some extrema, yes, it has some minimum. So 0, 0 is only a stationary point for this problem. No saddle point, no inflection, nothing, etc. Clear? Understood? Note down another problem. F of x comma y is equal to f of x comma y is equal to 2x cube plus 6xy square minus 3y cube minus 150x. Yes. First estimate the stationary point. To estimate the stationary point, we need to determine fx. Similarly, fy. Equate fx equal to 0. Equate fy is equal to 0. You will get two equations with two unknowns. Now you need to solve to get stationary points. Plus or minus? And then and then and then So if the same problem asked in the examination, lot of answers. So many object answers. A, B, C. The problem is once you got the two equations, see what is the first equation you obtained? If fx equal to 0, you obtained x6x square plus 6y square minus 150 equal to 0. This implies if I solve it, x square plus y square is equal to 25. This is one equation. Fy is equal to 0, I will get 12xy minus 9y square is equal to 0. If I can little bit rearrange it, I will get y into 4x minus 3y is equal to 0. This is what fx case, fx equal to 0 case. This is what fy is equal to 0 case. Now check for the stationary points. Look at the board. See, if y into 4x minus, have you got this equation or not first of all? Now I took y common. No, this y into 4x minus 3y equal to 0 means either y equal to 0 or 4x minus 3y equal to 0. Is it okay? Now keep y equal to 0 here, you will get x equal to plus or minus 5. So that means one stationary point is 5, 0, another stationary point is minus 5, 0. Problem is not over. Still problem is there. And keep y equal to, because this may be 0, this may be 0. This 0 if I get here, fine. Okay. Now in this equation, if I substitute y equal to 0, x I got plus or minus 5. So the stationary point is x comma y, x comma y. Plus 5, 0, minus 5, 0. Two stationary points. Now same y equal to 0, if I substitute here, I'll get x equal to 3 by 4y. If I substitute same 3 by 4y here, I'll get y equal to plus or minus 3, x equal to plus or minus 3 I will get, y equal to plus or minus 4 I will get. So the stationary points are 3, 4 and minus 3, minus 4. Now there are 4 stationary points. Stationary point 1, 2, 3, 4. Now at every point you have to check for this condition. Now at every point, which point is saddle point, which point is point of inflection, you have to check. So sometimes the problems will give a sort of like this. You should not miss any point where the point may be a saddle point sometimes. Now check for every point, 5, 0, check, test it. 5, 0. 5, 0 is saddle point or stationary point? Testing 5, 0 for this case. Test at 5, 0. Which is 5, 0 is saddle point. Minimum. So answer is minimum. So 5, 0 is a stationary point because it has some extreme. Now check for minus 5, 0. Check for minus 5, 0. comma 4. Very good. 3 comma 4 will become a saddle point. 3 comma 4 will become a saddle point. Now check for minus 3 comma minus 4. 6 for minus 3 comma minus 4. You might have some doubt. Yeah, let me complete that one first. So minus 3 comma minus 4 you will get. Minus 3 comma minus 4 you will get. Huh? Come to a conclusion. Saddle point. Both 3 comma 4 and minus 3 comma minus 4 are saddle points. But 5 comma 0 minus 5 comma 0 has some maxima or minima. That means these two are stationary points, these two are saddle points. Now you might have a question. The asked question has a function of third order, but I obtained 4 stationary points. Is it fine? Why? I'm not finding the roots. If it is a third order, the roots may be 3. I'm not finding the roots, I'm finding the points. I'm finding the points. It may have 3, it may have 4, it may have 1. Depending on the conditions, it will suffice. Because your f dash should be 0, then that point is a stationary point. There are so many cases where your f dash becomes 0 according to the function. So 3 ఉంటే 3 పాయింట్లే ఉండాలి, 2 ఉంటే 2 పాయింట్లు ఉండాలి, రూల్ ఏం లేదు. అది మైండ్లో పెట్టుకోండి. అందుకే చాలా మంది డౌట్ వస్తుంది. ఎక్స్ క్యూబ్ ఇచ్చాను కదా, 3 పాయింట్లు ఉండాలి కదా, 4 ఎందుకు వచ్చే స్టేషన్ అని క్వశ్చన్ అడగచ్చు మీరు. నేను రూట్స్ కట్టట్లే. రూట్స్ కట్టుంటే థర్డ్ ఆర్డర్ అయితే 3 ఉంటాయి, సెకండ్ ఆర్డర్ అయితే 2 ఉంటుంది, బాగానే ఉంటుంది. రూట్స్ కాదు, ఇది పాయింట్స్, ఇది స్టేషనరీ పాయింట్స్. ఎక్కడ నా ఎఫ్ డాష్ 0 అవుతుంది, ఎక్కడ నాకు ఇన్ఫ్లెక్షన్ మారుతుంది, ఎందుకు ఇవన్నీ కావాలి అంటే నేను ఒక ఫంక్షన్ ఇస్తే నాకు అది మ్యాక్సిమాలో పడుతుందా మినిమాలో పడుతుందా. ఎందుకంటే నేను ఆబ్జెక్టివ్ ఫంక్షన్ కట్టినప్పుడు ఆప్టిమైజేషన్లో ఐ నీడ్ టు హ్యావ్ మ్యాక్సిమం ప్రాఫిట్స్ ఆర్ ఐ నీడ్ టు హ్యావ్ లోవర్ కాస్ట్ ఆఫ్ మ్యానుఫ్యాక్చర్. సో లో ఆర్ మ్యాక్సిమం మాట్లాడుతున్నాను అంటే మ్యాక్సిమా మినిమా నాకు తెలియాలి. మ్యాక్సిమం మినిమా తెలియాలంటే ఫంక్షన్స్ కన్వెన్షన్ ఎలా ఉన్నది, ఫంక్షన్స్ ఎలా మారిపోతున్నాయి అవన్నీ తెలుసుకోవాలి. కాబట్టి నేను ఈ పాయింట్స్ ఫైండ్ అవుట్ చేస్తున్నాను. నా దగ్గర ఉన్న పాయింట్ శాడిల్ పాయింట్ అనుకోండి, లేదా నా దగ్గర ఉన్న పాయింట్ క్రిటికల్ పాయింట్ అనుకోండి, దానికి డెరివేటివే రాదు. డెరివేటివ్ రానప్పుడు నేనేం మాట్లాడతాను? శాడిల్ పాయింట్ ఉంది, ఇట్ డస్ నాట్ హ్యావ్ ఎనీ ఎక్స్ట్రీమా అంటే మ్యాక్సిమం ఉండదు మినిమం ఉండదు. అలాంటి కేసెస్ వస్తే నేను ఇంకెక్కడ ప్రాఫిట్స్ వస్తాయి నాకు? అది మ్యాక్సిమా అని చెప్పలేను, మినిమా అని చెప్పలేను. సో వెన్ ఎవర్ ఐఎమ్ ఫార్ములేటింగ్ ద ప్రాబ్లమ్స్, ద ఫంక్షన్స్ ఐ నీడ్ టు లుక్ ఫర్ విచ్ పాయింట్స్ ఇట్ మే కన్. సో దట్ ఈస్ వాట్ ద క్వశ్చన్. సో నోట్ డౌన్ ద ప్రాబ్లమ్. f of x is equal to 4 plus x cube plus y cube minus 3xy. 4 plus x cube plus y cube minus 3xy. Do it. So again multivariable. So you have to go by the same procedure. Very good. 0, 0, 1, 1. So those two are the stationary points. Now check for these points. 0, 0, 1, 1. Stationary or saddle? Check it. మ్యాథ్స్ స్ట్రాంగ్గా ఉండాలి, గుర్తుపెట్టుకోండి. గేట్ కొట్టాలి అంటే మ్యాథ్స్ స్ట్రాంగ్గా ఉండాలి. గేట్ కొట్టకపోతే సంబంధం లేదు. గేట్ కొట్టే వాళ్ళకి మ్యాథ్స్ స్ట్రాంగ్గా ఉండాలి. నేను ఇచ్చేవన్నీ చిన్న చిన్న డెరివేటివ్లే, పెద్ద పెద్ద నోట్లే. So 0, 0 stationary point, saddle point. 0, 0 is a stationary point or saddle point. Very good. So 0, 0 is a saddle point. Now what about 1, 1? Check for 1, 1 case. For 1, 1? One, one. Very good. 1, 1 is minimum. So 1, 1 is minimum. 0, 0 is saddle point. Yeah, note on the problem. 3x square y plus y cube minus 3x square minus 3y square plus 2. Now check for these stationary points first. Check for the stationary point first. for the stationary points. Zero comma stationary points. Zero comma zero, very good. Very good. 0 comma 2, 1 1, very good. Very good. Minus 1. So 4 stationary points. 0 0, 0 2, 1 1, minus 1 comma 1. Now check for the conditions. Yes, come on, solve the problem without noise. So every time you depend on others only. If you are not solved, you have to depend on others. అది మానుకోండి ఫస్ట్, ట్రై చేయండి. రాకపోతే హాస్టల్కి వెళ్ళి చెప్పించుకోండి. ప్రతిసారి వాడు చేస్తేనే చేస్తాం అనుకుంటే ఇంకంతే. Now check for every point. Which are saddle points, which are stationary points I want. Yes, 0 comma 0 is very good. So it's a stationary point having maximum. 0 comma 2, 0 comma 2, 0 comma 2. So you'll get minima at 0 comma 2. 0 comma 2 is again a stationary point having minima. Now check for 1 comma 1. Very good. 1 comma 1 is saddle point. Minus 1 comma 1. Good. So very simple, though the multivariable functions look a little bit tough, but once you determine the stationary points, if you remember the conditions, it is very easy to identify whether they are stationary or saddle points. Okay. Now in the last your seniors, I have asked this question: f of x is equal to f of x comma y is equal to e power minus x square plus y square. So this question I asked: f of x comma y is equal to y square. Better you can solve now. Yeah. So e power minus x square plus y square. I'm giving the answer. 0, 0 you will get. That is the stationary point. You have to check. Fine. So I'm giving the answer, but you need to check. How I got 0, 0, you have to check. Now just look at page number 139 of your Himal Blue textbook. He's asked for finding the extrema. If you look at the function here, the f of x is equal to 4 plus 4.5 x1 so on, x1 power 4. I can give the question also, but only thing is it's a simple problem, but only thing is it looks like a difficult one, but once you solve it is very simple. So this function he has given and he has followed another way, but I have given very simple way. And if you know this way, whatever the problem he has approached, the way he approached to get the stationary points will be lengthy. See, if you can check, he got some 3 stationary points, 1, 2 and 3. And out of the 3, first 2 are having local minima, that means both are stationary, but last point is a saddle point. So you can note it down, example 4.11. You can go and check in your textbook. Fine. So, and then look at the exercise problems. See, exercise problem starts from 142 page number in Himal Blue. 142, your starts problem 4.12, almost 4.50. That means 50 problems are there. 4.12, 4.50. And out of these 50 problems, some of the problems I already solved in the classroom itself. If you look at all the problems in the notes, some of the problems I already solved in the classroom itself. Finding the stationary or finding convex or concave, maybe single variable or multivariable, or finding the maxima, or finding the Hessian matrix. So many of the problems I solved in the classroom itself. But some problems are left. So that problems I may ask in the midday. So you need to solve those problems. Okay? At least otherwise, I'll give some of the problems from the exercise which I unsolved, maybe 10 or 15, among the 50, among the 10 to 15 which are questions, I'll give one question in the mid. Already I told in the assignment one question will be given, and out of the 10 or 15 I'll give, out of the 50 problems in the exercise, one question I'll give in the mid.
Fine. So maybe you can, on your interest, if you solve 1 to 50 problems, that's fine. Otherwise, you have to solve the 15 problems I will give from this book, because you will get a question from the mid exam. And that 15 problems I'll give such a way that will have good weightage in the actual exam also. Because the more number of problems will come in the exams, I'll check, and those problems I will put it. Okay? And that I will send to through email. So 10, or at the max I'll give 15 out of the 50. And those problems you have to solve. Otherwise you will miss in the mid exam. Clear?